So there's just a couple things on the study guide that I want to go over. I actually kind of adapted some questions from old or released practice items for your state test in May. And so a couple of the questions on here have been, like I said, kind of adapted or taken from old tests so that you can kind of see maybe a little bit what to expect. So when you're looking at these questions, right, where are you finding the heat source? Is it going to be here, here? Where's it going to be? Somebody describe to me. Sarah? It's going to be at the bottom, right? So that's the first thing that I would always do is find where the heat source is going to be. And we know that the heat is coming from the interior, so the most central portion of the earth. Right? And it looks hotter, right? The picture actually shows like it's looking hotter. So from there, you just have to decide, okay, what's happening when something gets warm? Well, we know that, obviously the material is going to heat up if it's by something warm, right? And then once it's heated, what happens? Well, we know that it's going to become less dense and it's going to rise, right? And so that would show what's happening at B. And then when you're away from the heat source, what happens?
It starts to go cool down.
You go cool it down, right? So just think of yourself as being close to a bonfire and then stepping away from a bonfire, right? If you're farther away from that bonfire, which we're saying is down here, then it's going to start cooling down. And then what happens density-wise when things cool down? What happens to the molecules? Yeah, they become more dense, and so they pack in tightly and become more dense.
Do we get s'more stuff with this bonfire?
Sure.
Yes.
Yes.
S'mores.
Good. All right, so just kind of want to talk through that again. Let's see. A lot of this is making sure you recognize the characteristics, obviously. All right, this one. So it says instruments located around the earth record seismic wave activity, during an earthquake, and the epicenter of the earthquake and locations of 4 instrument stations around the earth are shown. So these are seismograph stations, right? And it's showing the epicenter. So you have to recognize that the epicenter is that origination or beginning location of the earthquake, right? So if the earthquake starts here in the lithosphere, and then it's going to send the waves out. So that's what I'm picturing in my mind. Here, radiating out from that location, all right? So the question says, using the diagram below, identify the 2 stations that would not receive any seismic waves. So how many answers do you have to select? 2. You have to do 2, not 1, not more than 2, it has to be exactly 2. And there will be questions, and we're going to look at a bunch of other practice things as we start to get closer. But usually they're going to tell you, like identify 3 or pick 4. Every once in a while, like they used to say, pick all that would be correct. They kind of moved away from that and actually give you a more firm number. So just use that. If they give you a number, make sure that that's how many answers you're choosing, because if you choose anything different than that, then you're not going to have any chance of getting the credit, right? Same thing with the Google form, right? It has to be exact. So how would you go about walk me through how you came up with answers on this one. So a lot of you got this right. How did you know? Okay, what stations are not going to get any of that seismic? Like, they're not going to know. Like, so maybe at station 4, they don't even know an earthquake happened. They're not picking up any seismic activity. No S waves and no P waves are being detected. Tell me, Shelby, how did you figure it out?
Because the shadow zone.
Okay, so that's awesome. The shadow zone. Think of what a shadow is. If this is the light and it's hitting my hand, this area here is not receiving the light. My hand is blocking it. That's what a shadow is, right? It is blocking the light. And so the shadow zone is exactly that. It basically is existing because the layers have been changing or refracting those seismic waves, and it changes them and they're not able to get through, right? The Bill Nye that we watched, where he took the can and was drawing the lines right there at the very end of that Bill Nye, And I think that does a really good job of showing how the seismic waves get blocked, in certain locations. What stations do you think would not receive these waves? What do you think, Macy? Okay, so she says 2 and 3. How did you come up with those answers? Okay, so you were thinking, I put my head where the epicenter is, and then like I give myself like the little spirit fingers, right? If I put wherever the epicenter is, put my hands the exact kind of opposite, like my spirit fingers, right? And so because it's here, if I would put my hands down, it's gonna be right in this area. Okay, and that'll get you close, yes.
You could also make a star, like the bottom 2 points of the star, or in this case, the top 2 would be the ones that would receive it.
Okay, so like if you go like this,
Yeah.
yeah, good. And that's kind of what they actually drew with the Bill Nye, in a way. They didn't connect them to make the actual shape of a star. Good, so if you have a way that works, go with it, right? So stations 2 and 3, and then it says for the 2 stations that you selected, why did they not receive any? And again, they are, if you recognize that they're in the shadow zone, that's great, but all of the answer choices have shadow zone, so you have to narrow it down more. Says because some of the waves got blocked by weather events at the Earth's surface. Anybody like that? No? Okay, so the seismic waves are not, or the seismogram stations, they're not picking up weather. And so sometimes people think, oh, earthquake, that means it's gonna be some kind of weathering event. And so they put that in there to try to trick you, right? There are shadow zones because certain layers of the earth reflect and refract. Well, that sounds pretty promising, right? Let's make sure that the other answer choice isn't better. So it says they are in the shadow zone because some seismic waves are blocked by oceans.
That sounds kind of weird.
Yeah, and good. So those were the actual wrong answers that they had on the actual practice test or the release test item. So a lot of times people also think, okay, well, there are oceans there. So they try to put in enough that is factual to make it trick you into picking the incorrect answer. When the correct answer actually was the waves get reflected and refracted as they go through those different layers that have different densities, slows them down, speeds them up, that kind of thing. I think those were the ones that I really wanted to go over with you. Any other ones that you weren't sure on? A few of you asked me to explain a couple things, which was great. Good. Okay. So let me